We've got some problems about L'Hopital's rule. And L'Hopital's rule is a really interesting piece of mathematics. We're not going to have time to go into why it works, but I'm going to show you how to work it. Basically, with L'Hopital's rule, we're using differentiation as a tool for finding limits. Sometimes you want to find a limit as x approaches 0 or as x approaches infinity, but you can't really do it because you can't plug in 0 because you've got it would end up making the bottom of the function 0 or something like that. And so you have to algebraically manipulate the function into something different in order to evaluate the limit. And we've done that before. L'Hopital's rule is kind of another way to do that, and it works when you have what are called indeterminate forms. So this 0 over 0, if the function evaluates to 0 over 0 at the place you're trying to evaluate the limit, or if it evaluates to infinity over infinity. And L'Hopital's rule is pretty simple. What it says is, in those cases, you can take the derivative of what's on the top and the derivative of what's on the bottom and evaluate that, and it will equal the limit. So let me show you this in a couple of problems. So we've got, in this first one, 1 minus the cosine of t minus 4 over the sine of t squared minus 16. And if we put in, we're trying to find the limit as t approaches 4. If we put in 4 on the top, we'd get 4 minus 4, so that's 0. That would be the cosine of 0 is 1, so we'd get 1 minus 1 on the top. And on the bottom, t squared is 16, so we'd get the sine of 0, and the sine of 0 is 0, so we'd get 0 over 0. Aha, it is that indeterminate form. We can't calculate the limit there, but we can apply L'Hopital's rule. So let's take the derivative of the top and the derivative of the bottom. So taking the derivative of the top, that 1 is a constant, it's going to go away. The derivative of the cosine is the negative sign. Since I have a negative cosine here, that'll be the sine of t minus 4. And I didn't bother applying the chain rule because when you take the derivative of t minus 4, it just comes out to 1. So we don't have to worry about that. Let's try the bottom. So here, the derivative of the sine is the cosine. So I'm going to have the cosine of t squared minus 16. I do need to take the derivative of that to apply the chain rule. So that's going to be 2t. So 2t times the cosine of t squared minus 16. Now, let's try putting in 4 again. On the top, we're going to have the sine of 0, which is 0. And on the bottom, let's see, we're going to have the cosine of 0, which is 1, times 2t, so 8 times 1. So we're going to have 8 on the bottom. Now we've got a number. 0 over 8 is a number. It's the number 0. So this limit evaluates to 0. Let's try one more of those. All right, here we've got a complicated looking thing. We've got the natural log of 1 plus x over the natural log of 1 plus e to the 4x, and we want to evaluate it at infinity. Of course, you can't just plug infinity in for x. And just looking at this thing, they're both going to get bigger and bigger. The natural log, as x approaches infinity, kind of slowly goes up, so it's going to approach infinity too. Which one of these is going to get to infinity first, I guess, or is going to be winning that race is what we need to determine. So we've got a form where the top is going to be infinity and the bottom is going to be infinity. So this is another indeterminate form. So we can apply L'Hopital's rule. So let's take the derivative of the top and then the derivative of the bottom. For the derivative of the top, the natural log of something is going to be 1 over that something. So 1 over 1 plus x. And then we'd need to multiply by the derivative of what's inside here, applying the chain rule. But what's inside the derivative is just 1. So that doesn't apply. Okay, and now for the bottom, looks like we have to use the chain rule a couple of times. So first I'm going to say u equals 1 plus e to the 4x. So we've got the natural log of u. That is 1 over u, and then we have to multiply that by the derivative of u times du. Well, I want to also do some substitution here to take this derivative. I don't have to worry about the 1, but e to the 4x, we could say v equals 4x, and e to the v, the derivative of that equals e to the v. times the derivative of this, which is 4. So if we if we put all of that in, so the derivative of u is going to be e to the 4x multiplied by 4. So 4 times e to the 4x there. And then we've got 1 over u, and u here is 1 plus e to the 4x. And let's see, we can multiply this on the top. So let me rewrite this whole thing. It's getting complicated. I've got 1 over 1 plus x, and then I've got 4 e to the 4x over 1 plus e to the 4x. So what happens when we put infinity in here now? Well, what happens here is we get a really big number on the bottom. So this definitely is still going to infinity. What happens here, though, is we only have the x on the bottom. So this fraction gets smaller and smaller. So we get 0 there. So I think this limit evaluates to 0. So that is a little bit of work applying L'Hopital's rule.